Okay, yeah. So good evening, guys. Welcome to KodeCamp 2.0 Android training. So yeah, today we're going to be looking at animations in Kotlin, Android. Yeah, we're going to be looking at animations. Okay. Now, so animation is actually it's a tool that helps. A very powerful tool actually that helps users to, you know, understand the complex and confusing screen full of information. Okay. Assuming you have a screen where there's a lot of information, animation helps users rather to understand what is actually going on. Now, when a single item, for example, is updated, okay, animating that change helps the user understand what just happened. Okay, when items change, when animations can help transition the user from one UI to the next so that they understand the context and implications of what the changes. Okay, now there are different kinds of animations that you can actually use in your UI. Okay, we have the when items fade. Okay, when they fade out, that's when they disappear, or when they move onto the screen, or some basic geometric shapes can transform into different ways. So now animations can run by themselves. Okay, they provide motion to single objects, as it actually changes what its state. Okay, now Android actually provides facilities, okay, for animating UI objects. Okay, so the approach that we're going to use, okay, and the APIs or the tools that we'll use to create these animations is actually dependent on the effects that you're trying to actually achieve. Okay, but for this class, we're actually going to be using the object animator. Okay, so it's just it's the basic building block of most Android animations. Okay, now property animations are used to animate, that is, or change over time the value of a property on an object. So we'll get to use that. So this is basically what we're going to be building. So we have this UI. Okay, so we have this star. So we have these various and stuff that we can do: rotation, translation, scale, fade, sky color, and shower. So we're going to actually, you know, build this. Okay, so we're going to animate the star on the screen. So you can see this now. I'm just going to switch to the main activity. So this is just some setup. I hope you have actually cloned this um, project. I think I dropped the link on the channel. Yeah, so we have 5 buttons here. Yeah, 6 rather. We have about 6 buttons here. Okay, and then we have an image, and then we have the image is contained in a frame layout. Okay, it's contained in a frame layout. So this frame layout is going to act as our background. Okay, so the rotate will just cause the star to spin in a complete circle. The translate will cause the star to move to the right and then back. The scale will cause the star to scale up and then back down. Fade will cause the star to fade out to be completely transparent. Okay, and then back to be fully opaque. Okay, then the sky color will cause the color of the stars container, which is this frame layout, okay, to animate between 2 colors, whatever color that we decide to choose. Okay, and then the last one, which is the shower. Now the shower will create a new star at the top of the star field, which will then fall downwards while rotating. Okay, so every click will create a new star, animating it in a parallel, animating it in parallel with the existing stars. So yeah, there's a lot of things we're going to do today. Okay, I really hope we'll have the time to, round all those up. Okay, so basically what you're going to be learning today is what properties are and how to animate properties. You're also going to learn how to use the object animator to animate your UI elements. You're also going to learn how to configure your object animator for different UI animation situations. I'm also going to learn how to use the animator set to create more complex animation of several parts. And then lastly, you'll learn how to use animator listeners to set up the initial and then final states of objects that are being animated. Okay, like just like removing views after you've faded them out. Okay, so that's basically what we are going to be looking at in this in today's class. Okay, so let's move forward now. So on the main activity, so we have, like I said, we have about 6 buttons. Yes, the rotate, translate, the scale, the fade, the colorize. There's a color button in the shower, and then of course we have our image. Now each of them I've already set up an on-click listener. So the rotate has a rotate function, okay, which for now doesn't do anything. So we'll work on that. Translate has a translator function. So when you click on each of these buttons, the corresponding function is being called. Okay, so we're going to now make use of that. Okay, so I hope. So let's start. So the first one we're going to actually do is to rotate the star. Okay, so that's the first thing we're going to. Let's implement the rotator function. Okay, to rotate the star. So what we're basically going to do now, we're going to create an animation. Okay, we're going to create an animation in this function. We're going to create an animation that will rotate the image view, okay, that contains that star from a value of -360 to 0. Okay, so what this means that the view and the star inside of it, okay, because we have an image view and then we have an image, okay, it will rotate in a full circle, that is 360 degrees. Now, the reason that the animation starts at -360 is that it allows the star to complete a full circle, that is 360 degrees, and end at 0. Okay, of course, that's the default rotation value for a non-rotated view. So it's actually good to, it's actually a good value to have at the end, that's 0. Okay, so this is how we're going to do that. So we're going to create an animator. So I'm going to say animator. So we're going to call the object animator class, object animator. So we have the dot of float. Now, so the first thing we're going to pass, okay? So the first thing we're going to pass is the image, okay? So you can see from this constructors here, you see target. So what are we targeting? We are targeting the image, and that is our star, okay, which is our image view. So that is what we are targeting, okay? Now, the next thing that we're going to pass, so the next thing we're going to pass is what exactly do we want to do, what exactly, so which is we want to rotate it. So I'm going to call the view dot rotation, and then of course we need to pass in the values. So like we said, -360, okay, and then stop at 0. Okay, so basically what this line of code does is that it creates an object animator, okay, that acts on the target, and our target is the star. It acts on the target, and our target is the star. Okay, so now it runs an animation on the rotation property of the star. Okay, it runs an animation on the rotation property of the star. So it changes to that property now, okay, will cause the star to rotate around its center. So now let me show you something. So there are actually two. You can see we have rotation X, we also have rotation Y. Okay, so these ones, they rotate around the other axis, that is in 3 dimensions. Okay, but they are not typically used in UI animations, since UIs are typically just 2 dimensions. So we're just going to use the rotation. Now, so at this point, I would want us to look into 3 things, just some definitions. Okay, now the first is what is a property, what are view properties, and then what is a property animation. It's very important that you know this. Now, a property to the animation system is just a field that is exposed, via getters and setters. Okay, a property in animation, to the animation system is a field that is exposed via setters and what getters. So it's exposed either implicitly, that is, as properties are in Kotlin, where you use the access operator, just dots, sort of set text, you have dot text, okay, or explicitly. Okay, so the explicit one, of course, via the setter getter pattern, just like Java does. Okay, so now there are also there's a special case of properties exposed via a class called the Android.util.property, which is used by the view class. Okay, so what is it? Actually allows a type safe approach for animations. We'll see that as we move on. Okay, we'll see that. So the Android system, the animator system rather in Android was specifically written to animate properties. Okay, meaning that it can animate anything, not just UI elements that has a setter. Okay, so just to note that. Now, the next thing is the view properties. Okay, the next thing is the view properties. So view properties are a set of functionally added. They're like functionally added to the base view class. They allow all the views to be transformed in specific ways that are useful in UI animations. Okay, so they are properties for position, like called translation, rotation, scale, transparency. Now, transparency actually is called alpha for some of us who have actually, played around with stuff like that. Okay, so there are two different ways to assess the properties. Okay, by your regular setter and getter pairs, just like you have okay, let me see. You have this what we call the set translate. Okay. Oh, just typing that out. So it's not like I'm expecting it to. So you have like the set translate, okay, or / the get translate, okay. And then, but if you are using set translate X, now, but if we are using the property, we're using the property, this in the Android or util the property objects, okay, just like we use what we call the view dots, and then we just assess that rotation X, okay. So we can actually have there's actually a view. So let's see. You have the word translation X and the likes of them. Okay. So that's basically that. So there are two different ways to assess it, either using getters or setters, okay, or by the static Android.util.property objects, just like a view dot maybe translate, view dot rotate, and the likes. Okay. So now that's an object actually has both a get and a set. So we actually, of course, we actually know that that's one of the things that Kotlin actually made a bit easy. So you don't have to set a text, you don't have to get a text. So you don't have to create those setters and getters anymore. You just have to call the assess it using the dot operator. Okay, so that's actually that. Now, the last thing I would want to just define is the property animation. Okay, the property animation. So the property animation is simply the changing of property values over time. That's basically what it is. Changing of property values over time. That's the property animation. Now, the object animator was created to provide a simple set and forget mechanism for animating properties. That's, for example, you can define an animator that changes the alpha property of a view, which will alter the transparency of that view on the screen. Okay, so that's just certain definitions I actually just wanted us to get to actually note. Now, so back to our rotator function. Yeah. So how can we now run this? So it's very simple to run the animation. Okay, to run the animation, I'm just going to say animator dot start. Yeah, that's all. I'm just going to say animator dot what start. Okay, so let's run this application and then let's see what that does. So I think I'm just going to have to share my whole screen so that we can get. Okay, so let's run that quickly and let's see what we have. Okay, so okay, that's it. So let's see. So when we click the rotate, you can look at the star. So you see it rotates. It what rotates. Okay, so that's good. So it actually just spins around the center, but it does, if you check, it actually does it so quick. No, it does it so what quick. In fact, actually does it in 300 milliseconds. Okay, and that's the default duration of all animations on the platform. So 300 milliseconds is actually it's a decent, it's a very nice default for most animation. But in this case, we actually want to enjoy the animation. We don't want it to be too fast. Okay, so how can we reduce this? Okay, so just before the animator dot start, I'm going to say animator dot duration, and then let's use a 1000. Okay, so 1000 what milliseconds. Let's use that 1000 milliseconds. So I'm going to run that, and then let's see. Okay, so click on rotate. Yeah, it takes its time. It doesn't rush. So that's actually so now well, we're actually not done. So now, in as much as this is cool, there's one thing we would want to avoid, and that's called a discontinuous motion. Okay. Now, assuming you're someone who doesn't have a lot of patience, okay, and you actually run this animation again, okay, you actually notice a jump when you click on the button. Okay, if you something like a jump. And the reason is because we are actually resetting it to 360 degrees at the start of the animation. Regardless of whether the star is currently in the middle of animating or not, assuming I just keep on clicking, you notice there's this jump. There's this jump. So because it resets to minus 360 degrees at the start of the animation, regardless of whether the star is in the middle of animating or not. So this motion, this discontinuous motion is an example of what we call a jank, Jank, okay? Because it causes a disruptive flow for the user instead of a smooth experience you would actually prefer or love, okay? So it's one of the things you'd want to avoid. Now, there are actually different ways of handling this, okay? One of which could be starting the new animation from where the current value is, okay? But to keep things a bit simple, we're just going to prevent the user from clicking the button while the animation is running, okay? So that they can enjoy, the whole process, okay? So now to do that, animators actually have a concept of listeners. Okay, animators have a concept of listeners that call back into, which calls back into the user code to notify the application of a change in the state of the animation. Okay, so there are callbacks for an animation starting, ending, pausing, resuming, and repeating. Okay, but what we actually just want to do here has to just do with the start and end. So basically, we want to disable the rotate button as soon as the animation starts, and then enable it when it actually ends. That's basically what we want to do. So before the start, I'm going to add a listener. So say animator dot add listener. Okay, so I'm going to use the lambda, or well, we just use this. So and then we'll add a listener there. I'm going to say objects. Then I'm going to call the animator listener adapter. Okay. So let's see. Okay. Cool. Okay, so yeah. So we're going to override two functions here. The on starts, sorry, on animation starts, yes. So we're going to, yeah, on animation starts. Okay, so what we're going to do, so when it starts, the rotate button, okay, we're going to what disable it. So if dot is enabled, so we're going to pass in false, okay, and then for the end, so on animation end, I'm going to enable it. I'm going to pass in true. Okay, so that's that. So let's confirm that that actually works. Let's confirm that works. Okay, so when I click on the rotate, so it's in. You can actually see it's disabled and then enabled after that. So well, to actually see it for a much longer time, I could let's so instead of 1,000, how about we just say 700? I think let's see if that would make it make it a bit slower though. Okay, so you see it's yeah, okay. Not really, yeah. Okay, so I think 1,000 milliseconds. So that's actually that. Let's take that back. So the rotate button is disabled as soon as you just start the animation, and then it's enabled again when they are re-enabled rather when the animation actually will end. So with that, okay, each animation is completely separate from any other rotation animation, and that avoids jank, okay, of restarting in the middle of rotation, okay. So that's actually that for the rotation. So let's go to the next one, which is to translate, okay, to translate the star. Okay, so let's see. We already have a listener on the translate button. Okay. Okay, so let's now create an animation. Let's create the animator. So I'm just going to copy this. For the translator. Okay, so I've created an animation. So so this is now going to be view.translate X. Okay, so before I explain, let's just run this and let's see. So animator.start. So let's run this and see what happens when we translate. Okay, so when I click on translate, you see what happens. So what's really going on? So because if you notice, when you click on it, the star moves to, it moves to the left. So let's change this. I think, okay, should take out this value. So we should actually just have 200F. That's fine. Okay, so let's, yeah, this makes sense. Okay, so what happens? Yeah, so this just moves to the right and then stops. So this is another thing. This moves to the right and then stops. So what's actually happened here? It doesn't actually come back, just like what we had before. So that was going to the left and returning. But when we just take out that value, okay, well, so just give it that. So I'm going to explain. Now, first of all, okay, the animation is only being set to run one way. Okay, our animation is set to run just in one way. So it animates, now the 200 here means that it animates the star 200 pixels to the right. Okay, it animates the star 200 pixels to the right, and that's it. So if you want it to come back, we're going to need to add something extra if we want it to come back. We're going to need to add something extra. Okay, so also subsequent animations does not appear to do anything because we've actually set it to run to a value of 200. So it doesn't do anything. So even when we clicked on it again, nothing happened. Nothing happened because the value is already at 200. So there's no place to go. So we're going to fix these problems by using the concept of repetition. Now, repetition is just a way of telling animations to do the same task again and again. Okay, you can actually specify how many times to repeat or just tell it to run infinitely. You can tell it how many times to repeat or just tell it to run infinitely, okay? You can also specify the repetition behavior, either reverse, that is, for reversing the direction every time it repeats, or restart for animating from the original start value to the original end value. So there's a lot of things you can actually do, okay? So first of all, let's change the animation to repeat. Okay, so I playing in reverse back to the starting position. So what we'll do, okay, I'm going to set the animation, the repeat count. So I'm going to say animator.repeat count. Okay, so I'm going to just pass in a value, repeat count. I'm going to pass in a value of 1. So this repeat count property, okay, controls how many times it repeats after the first run, okay, as well as the type of repetition. So we also need to pass in the type of repetition, whether we want to do a reverse or a restart. Okay, remember the reverse means that you're we're reversing the direction every time it repeats. The restart means is gets to start from the original start value to the original end value. So we're going to add what we call repeat mode. And then the repeat mode is just going to be, so I'm going to call the object animator class and then dots. So let's use the reverse. Okay, so let's run this again and then see what changes we have here. Okay, so translate, you can see back and forth, back and forth, back and forth. Now let's just, for curiosity, let's change this to restart, just for curiosity's sake, and then let's see what happens. So you can try this, you can play around with this, play around with them, and then, so you see what happens. And then, of course, just once it's done, because it has actually gotten to the end value. Okay, so that's actually that. So let's take this back to reverse. Okay, so we could actually see that the button animates to the right and back when we actually use the reverse. Okay, that's unless you click the button again while it's running. Now let me show you what I mean. So when I click on it goes front and back, but when I click on it continuously, it just goes to the end and then it stops. Okay, of course, this should not be that way. Of course, I'll probably want it to just keep trying to go back and forth. See, whenever I stop, then it should go back. Okay, so that's a problem. Now, but the problem here is different than what we had before. Okay, now here the star would actually snap back to its starting point, to begin the animation again. But here the animation does not snap and doesn't go back. Okay, it doesn't go back. Instead, it starts animating from where it's at, but it doesn't go as far. Like, for example, if just like we did restart, okay, if you start it halfway through its return trip, that is probably when it's at 100, then it will start the new animation from 100. Let me show you what I mean. Restart. So let's say halfway through, I then click again. So it's just, what basically that does is that it returns, it restarts halfway through its return trip when it's at 100. Then to start the new animation from 100 now, but it will only go to 200. It's not going to extend more than that end, that's 200. Okay, so the overall animation is much shorter because it started from a value greater than 0. So that's if when you clicked on it at the very first time, you now click on it again, probably halfway through. It starts from there to still count. So it doesn't start from, so it doesn't go back to, it starts from there to count. But once it hits that 200, it doesn't go more than it should. So basically what's actually going on. Now the difference here between this particular animator and the animator we used for the rotation, okay? The difference here is this. Okay, back to reverse. So the rotation animation was given both start and end values. Okay, so it always ran to the animation between those two values. But here we're giving the animation only an end value. We're giving the animation only an end what value. So when the animation actually starts, it first queries the current value, okay, of the translation property on the star, and it uses that as its implicit start value. So animating from that value to 200. So when you click on translate, when we click on the translate button, when the animation is, part of, almost through, it grabs that value, that midway value as the starting value for the new animation, and then runs the animation over to its, so it's going to be a much more smaller distance to get to 200. So let's prevent, restarts while the animation is running. Let's prevent that. So just like we did, before, we can actually just prevent that, so you don't actually have to click on it. So fix it a similar way we just did. I'll just disable the translate button. Okay, we'll just disable the translate button during the animation. So so now if you notice, we're going to be writing this same function again. Okay, so let me just show you something. So we're going to need this. I'm just going to copy this. Okay, this is basically what we're going to need. So instead of the rotate button, what do we have? We're using the translate. Yes, translate button. Okay, yeah, that's basically what we want to, so to disable it. Now, but since this is the second time that we're actually writing very similar code, that's just adding, a listener to enable and disable. So we can actually just create a separate function that we'll use everywhere we need it. Okay, so I'm just going to create a function down here. Of course, it can be a private function. And I'm going to call it disable view. Okay, so I'm going to call it disable view. So now this is going to take, now, because we need to, if you look at what's, what are the things that are common here. So it's going to take a view. And then the next is going to take an animator. Okay, it's going to take an animator from the, this one. So we'll use that to, okay. So with this, and then I'm just going to override that. So on, sorry, just, so animator, dot add listener. So just, no need, just, I remember I copied it before, so yes. So this is it now. So instead of rotate button, so since we're going to be passing in a view, so I'm just going to say whatever view I pass in, dot enabled is enabled. Okay, going to be what? False. And then I'm just going to copy this. So it's good to always have, and then this is going to be true. Yeah, so with this function, okay, with this function, I can just call it here. So basically what I'm just going to do here, so instead of having the whole of this, I'm just going to call my disable view, and then I'll pass in the view. And the view I want to disable is the rotate button, and then of course pass in our animator object. So So same thing for this. Yeah, but here is now going to be the translate button. Okay, so that's actually that. Yes, so that's that. So that kind of just makes the code a bit, so you don't have to, write out a lot of listeners, here and there. So let's run that and make sure that everything works fine. Okay, so we have to reinstall and restart. Okay, so let's see the translates. Okay, disabled and then enabled. So that's fine. Now, so let's just to go, go further. Okay, now let's take advantage of Kotlin's features. Okay, by using extension functions. Okay, now I'm going to change this disable view function to be an extension function on the object animator. So basically what this does, it makes the function more concise to call since it eliminates a parameter. Okay, it also makes the code a little more natural to read by basically just putting the animator related functionality directly into the object animator. So what do I mean? So this is what we're going to do. I'm going to come down here. Okay, so let me create a function here. I'm going to say so let's create an extension function. So from the object animator dot, we are going to disable view. Okay, and I'm just going to pass in the view. That's all. And then I'm going to call this okay, so I'll add listener and then the objects. Okay, so I think yeah, John starts. So we have this. So yeah, that's fine. That's actually, where does this close out? Okay, good. So this is our extension function that we can always we can actually just reuse this. We can reuse this. So that being said, I'm just going to call now inside our translator function. So I no need to do this anymore. I can just say animator dot, and then I'm going to get my disable view and then pass in the view, which is the translate button. So that's actually how to create an extension function. Okay. Let's do the same thing to the rotator function, but here we're passing the rotate button. Okay, good. So that's actually how you do that. So let's run that and make sure everything is still fine. So that being said, we don't need this function anymore. We don't need that function anymore. So let's see, our translate works, our rotate works also. Yeah, so this is the helper function, extension function rather, that we're actually going to be making use of. Okay, so the extension function right now is now a function on the object animator. So we can call that function using our object. Okay, so that's actually that. Now, let's move on. Let's look at how to scale, scaling the star. Okay, now in scaling the star, this is basically what we're going to do. Now, when we're actually doing the rotation and then the translation, okay, we're basically just animating one property, but that's just what we need. We are animating just one property. okay, that is rotating around a single axis, which is the x-axis, which runs, okay, perpendicularly, right? And then the translation was along the x-axis also, which runs from left to right. Now, but when an object is scaled, it is usually scaled in x and y simultaneously to avoid, making it look stretched along one of the axes. Okay. Now, so we have to create an animation that will animate both the scale X and scale Y properties at the same time. Now, one very good thing to note is there's no single property that scales in both the X and Y dimensions. Okay, so animation that's scaled in both X and Y need to animate both of these separate properties in parallel. So, okay, let's just, now there are actually some ways to do this. One of them is the animator set. Okay, so the animator set, we'll actually see that later, much later, I think hopefully before round up. Okay, but a very good technique that I would want us to know about, it actually uses what we call the property values holder. Okay, it's actually an object that holds information about a property, about both a property and the values that that property should animate between. Okay, so one thing to note also is that this property values holder, it holds information about a single property along with the values that the property animates between. An object animator can hold multiple property values holder objects. Okay, they'll all animate together in parallel when the object animator actually starts. So the target that these property value holder objects animate is specified by the object animator. Okay, so let's create an animation now using this property values holder. Okay, so what we did here when we were creating this object, we actually supplied some values. Yeah. So we put information about the property. Okay. So this is what we're going to do in this case. So first of all, we're going to create two property values holder objects. Okay. So let's go to our scalar function. So first of all, I'm going to save our scale X. And I'm going to call property so I have the property values holder dot of float. Okay, and then I'm going to call the view dot scale X, and just want a for. So I'm going to explain what that does, and then so for the Y, so scale Y, and then a for F also. Okay, so now the scaling to the value of 4F, okay, it just means that the star will scale to 4 times its default size. That's basically what that means. Okay, it means that the star will scale 4 times its default size. So now let's create an animator object. So I'm just gonna try to reuse some stuff. So I'm just gonna copy this. So but I'm going to take this out. Okay, so dots of, we have the of property values folder. Okay, so that takes a target. Okay, of course, our target is a star. And then it takes what? Variable argument values of the property values holder. So which we have actually created, which is the scale X and then the scale Y. Okay, so this is similar to the animators we have created, previously. But now instead of defining a property and a set of values, it uses multiple property values holder that contain all of the information already. Okay, so let's just let's run this to make sure that we're good. To make sure that no errors anywhere. Yeah, Yeah, we know. So it's telling us that we need to start it. So we will as soon as. So let's just clean up this. Okay, so I'm gonna add the repeat count just like we did with the translator. So okay, repeat count. So 1, and then repeat mode. I could have just copied that, but well. So we're going to use the reverse. Okay, so and then we can now start it. Okay, so yep, that's actually that. So let's run that and see what happens. Let's run that and see what happens. Okay, so scale. So you can actually see 4 times its size. Okay, so assuming we want to make this an 8. Let's see. Yeah, you can see it makes it much more bigger. Okay, so that's scale. That's about scaling the star. So the next one is going to be to fade it. Okay, so let's see how can we actually fade this one. Okay, so we'll fade it to be completely transparent and then back to fully being opaque. So fading of items, well, they are very useful to transition them into or out of a UI. For example, when you're removing an item from a list, you might fade out the contents first before closing the gap that it leaves. Or if new information appears in a UI, you might want to fade it in. Okay, so this effect, it not only avoids discontinuous motion with UI elements snapping in and out of part of the user, but it actually helps alert the user that there is a change happening instead of just removing or adding items and making them guess what just happened right now. Okay, so we actually use the alpha property on a view, for fading. So alpha is actually a term that is generally used, especially in computer graphics, of course. So it denotes the amount of opacity in an object. So a value of 0 indicates that the object is completely transparent. And then a value of 1 indicates that the object is completely opaque. Okay, so view objects, their default value is actually 1. So animations that fade views in and out, that means they'll have values between 0 and 1. So in our fader function, so I'm just going to do this quickly. So I'm just going to copy what's in translate and then do some minor changes. Okay, so I think I didn't pick the V. Okay, so so this is now going to be view.alpha. Okay, and then of course I'm going to give it to 0. So just repeat 1 count and then reverse, and then the disable view, I'll call the fade button, and then let's start that. So that's actually just a bit straightforward, not really, nothing really to it. So for the fade, you can see that it fades and then comes back. So that's actually the fade. Okay, so the last, it's not second to the last. So let's look at the coloring. Okay, we want to colorize now. So this is actually one very powerful thing about Object Animator. Okay, you can actually animate anything as long as there's a property that the animator can access. You can animate anything. Okay, so let's animate. We can animate an arbitrary property. Now, what do I mean? So this is one simple example. Now, that is this colorizing. We're going to use the sky color button for that. Okay, so now in this one, the property isn't an android.util.property object, but instead a property exposed via a setter. I'm going to show you. which is the view.set background color. So since we cannot actually refer to the Android or YouTube property object directly, like we actually did with, what we said .alpha and that, we'll actually use the approach of passing in the name of the property as a string. Okay, so this name is then mapped internally to the appropriate setter and getter information. So for this example, we're going to do something now. So first of all, we're going to need the animator. So let's just get the animator first. Now, but for this animator, we're going to pass in star. So this is what we're going to do. Okay. So I'm going to take this out. So we need the animator object that can act on the appropriate type. So we're going to use the object animator dot of int. Okay. Now, say of course your set background dot color, it takes in an int. Okay, it takes an integer, but let's we could actually use that though, but well, it could give us some unexpected result. But let's just move ahead. So I'm going to say star, which is the view dot parent. I want to get the view parent and then dots. Now we have, okay, just the parent. Okay, good. And then we now have, like we said, a name that will be mapped internally, and that name is background color. Background color. And then, so I'm going to say color. So what do we want to change? Let's say color dot black, and then let's use green. Okay, and then we can just start it. So let's see. Couldn't find property setter method set around on the Android view parent. Okay, so let's see. So why can't it find it? So okay, so I think we'll have to let's find. Okay, so why couldn't it find it? Of course, view, of course it has a. I just want to check something. Okay, so should we say, so if we use background, so I don't know, maybe we may have to suppress that, but let's see. Let's just suppress that, and I think I'll figure out that. I'll figure it out. Okay, so so let's do something. So let's test it out. Let's test this out. Probably maybe missing something. So I'm gonna click on this sky color. So yeah, it actually works. Yeah, but so it's just that a lot of colors, a lot of colors. It flashes between many different colors from black to green. Okay. So basically the problem here is that the animation is interpreting the raw integers as colors. Okay, it's actually interpreting that. So when you're animating between two integer values, and like animating between two integer values does not necessarily yield the same result as animating between the colors that those two integers represent. Okay, so let's animate colors and not integers. Let's animate colors and not integers. So because we're animating integers, which is the of int. So what we'll need actually is that we need an animator that knows how to interpret and animate between color values. So rather than the integers that the colors, so we'll use a different method. We're going to use the of ARGB. Yeah, so we're going to use that. That's just what we're going to use. So let's run this now and then let's see. Okay. So you see from black to green, just those two colors. Okay. So it smoothly just does that without, throwing in, flashing in a lot of colors. So this of ARGB method is actually the reason that the app builds against a lower SDKs, that is ones with the minimum SDK of 21. So the rest of the functionality of the app can actually be run on earlier SDKs, but of the ARGB, it was actually introduced in Lollipop, actually. So that's actually that. Okay, so now the other thing to notice about this object animator that we actually constructed, okay, is the property. Now, instead of specifying one of the view properties, like alpha, we are simply just passing in a string, which is background color. So when we do this, the system searches for setters and getters with that exact spelling using what we call reflection. So it catches references to those methods and then calls them during the animation. So instead of calling the property sets or get functions as the other ones did, just searches for the setters and getters with the exact same spelling. Okay, so let's do a fade back to black. Like let's fade it back to the black because it went to green, okay, but it didn't go back to black. So how can we actually do that? Because we're able to go from black to green and it just stays there. So if we click the button again and again, it will always end up at green because the animation actually explicitly animates from black to an end value of green. So how can we actually do that? So, well, actually, first of all, let's make it run a bit longer. So I'm just going to, take out the start first. So I'm going to, let's set a duration. So with this, we can just set duration, or we can actually just say duration. So, but let's use it. So let's say 500. We just use the access, property access syntax. I think that's better. And then let's have the repeats count. So I think I'm just going to be a bit lazy right now and just copy and paste. Okay, and then of course the disable view, could have copied that. Sorry, disable view, and then of course we pass in the view, and the view is the polarized button. Okay, so with that we can start this, right? Yeah, animator. Sorry, animator.start. Okay, so that's actually that. So let's run that. So yeah, so you see, so from black back to green, black to green, then back. Yeah, so that's basically that. Okay, so that's that. So that's where the reverse comes in. So okay, so let's move on. Let's move on. Now the last one is the so let's see what we have here. Okay, the shower. Okay. The shower. So this is actually the last step. Okay. So basically, what we're going to do is, when we click a button, we want to clicking a button that results in the creation of a star with a random size that will be added to the background container, just out of the view, okay, of the top of that container. So the star will then proceed to fall down to the bottom of the screen. accelerating as it goes. So as it falls, it will rotate. That's basically what we want to do. So first of all, let's give birth to a star. So first, we're actually going to need some local variables, okay, that will hold the state that we're going to be needing to ensure, everything works fine. So first of all, we'll need a reference to the star field, and the field is the view group, okay? That's the parent of the container, the current star. So that's the first thing we need. So I'm going to say val container, okay, val container. So I'm going to say star dot parent. Okay, and then I'm going to say as view group. Okay, so the next thing we'll need is the width and the height of that container. Yeah, so because we'll use it to calculate the end translation values for the stars that will be falling. So I'm going to say container width. So I'm just going to use that view group and then get the width, of course, and then I can also the height. I'm going to say container.height to get the height of the container. Yeah, that's pretty simple. And then we'll need the default width and height of the star. Okay, because we'll actually use this later with its scale factor to get different, sized stars. So I'm going to save a star. So this was going to be of star width, and this is going to be of type float. So I can actually just do that. So I'm going to say star dot width, and then we'll convert it to a float. So we'll do the same thing for the height. And then of course, dot height, and then to float. So the next thing is to create a new view. So we have to create a new view that will hold the star graphic, okay? Because the star is actually a vector drawable, okay? Our star is a vector, okay? So it's a vector drawable. So we'll use the app compact image view, okay? Because it actually has the ability to host this kind of resource. So I'm going to do something. So we'll say var, okay, let's create it. So we're creating a new view now. We're creating a new view. So I'm going to say app compact activity, and then pass this. So this is just a new view. So that's approaches about that. Okay, so I've compact activity. Oh, sorry. So I'm supposed to use an app compact image views. Yeah, I was wondering why content layout ID. Yeah. Yes, that's that. Yeah, so that's the new view we need. So with this view, I can now set image resource, and then I'm just going to get the star. Okay, and then with that, so I'm going to use dot layout what params. So let's now do some stuff. So now we'll call our frame layout. Okay, frame layout dot layout params. So we need to pass in some stuff. So I'm going to say the frame layout, the layout params dot wrap content. Can I just duplicate this and then, yeah, for both of them, and then just close this out here. Okay, and then, so let me actually just, for us to not, hope you're not confused. So I think this closes out here. So hold on. Yeah. So I can now call my container dot add view, and then I'm going to add the new star. So that's basically what we have just done. So what did we do? We are creating a new star. Okay. So we said we get a reference first. Okay, we get a reference first, and then after that, we'll now get the width and the height of the container. We'll get the width and the height of the star. Okay, and then we now need to create a view that will hold that star. Okay, because our star is a vector drawable, that's why we can actually use the app compact image view. So it's just going to be able to host that resource. So we'll create a star, and then we'll now add it to the background container. So that's basically what we have done. So let's just run and see the effects of what we just did. Okay, so that's what we have. So let's see. So when I click on the shower, you can see a new star just got added here. Okay, you can actually see that. So a new star just got added. Okay, so we have actually created one. Now, let's now work on the size and the position of the star, because we have not actually told this image where to be positioned in the container. So it just positioned itself at 0, 0 by default. Okay, so let's fix this placement. So in our function, I'm just going to say, let's set the size of the star. Okay, so I'm going to say new star dot scale x. So let's give it a value. So I'm just going to call max dot a random value. To get a random value, convert it to a float. Okay, and then let's do some multiplication here. 0.5f, and then okay, let's just do 0.1f, and that's fine. Okay, so I'm gonna, so for the y, scale y, so I'm just going to say, so the scale for the y to just be the value of the scale x. Okay, and then for the star width now will now be our new star dot scale x, and then this star height, okay, will then be our new star dot star height dot scale y. Okay, so that's actually that. So with this, we have just cached the star's pixel height and width, and we've just stored it in the star width and star height variable. That's just what we have actually done. So now the next thing is to position the new star. So horizontally, it should appear randomly, somewhere from the left edge to the right, randomly anywhere. So we don't want to specify. So it should just appear anywhere. Okay, so we're going to do that, and then so this is how we're going to do that. So I want to say new star dot translation x. Okay, so I want it to translate anywhere horizontally. So let's do the math of random, get a random value, convert it to a float, and so we'll then multiply that by our container width minus our star width, and then of course we just divide that by 2. That's it. Okay, so basically what this code uses, it uses the width of the star Okay, this is the width of the star to position it from halfway off the screen on the left. That is where you have your star width divided by 2. Okay, to halfway off the screen on the right. Okay, with this, so this with the star position that where you have the container width minus star width over 2. So the vertical positioning of the star we'll handle that later. Okay, we'll handle that in the actual animation code. But this is just for the horizontal one. Okay, so let's just run that to be sure that everything is working fine and that we don't have any errors. Let's see. Okay, so shower. So you see it appears here. So it's random. Okay, another one appears. So it's random. You see, it's random with different values. It's random with different values. It's scaling it differently due to the random values it gets. Okay, so so let's create animators. Okay, for the rotation and the falling. Let's create animators for the rotation and the falling. So let's do. So basically, the star should rotate as it falls downwards. So I've actually already seen one way to animate two properties together. That is using the property values folder in our scaling function. So we could actually just do a similar thing here, except that there'll be different types of motion. And this is actually called interpolation. Okay, it's actually called interpolation. So specifically, the rotation will use a smooth linear motion that is moving at a constant rate over the entire rotation animation, while the falling animation will use an accelerating motion. So it's just basically going to simulate gravity, pulling the star downward at a constantly faster rate. So we're going to create two animators and we'll add an interpolator to each of them. So first of all, let's create the mover. So I'm going to say object animator dot off. So we're going to use the offload. So we're going to use our new star, of course, and then so we get our view dot. So this is for the translate y, translation y. Okay, and then the next thing we'll pass is a negative of the star height, a negative value of the star height. And then so we'll get the container height and plus the star height. Okay, so this is our mover, and then we'll now add the interpolator. So mover dot interpolator. Okay, so and then we'll call the accelerator interpolator. And then we'll just pass a 1f. Sorry. Yeah, that's the factor. Yeah, 1f. So that's for the mover. So we're going to create for the rotator. So this is what moves it. So let's create for the rotator. So I'm just going to duplicate. So I'll change this to, let's call it rotator. And then of course, uses the new star also. And then here is just going to be rotation. So, and then we're just going to do some other calculations here. So we're not going to need this. So for the rotation, so I'm going to call math.random. So it gets a random number and then it multiplies it by 1880. Okay, so 1080. Okay. Yeah. And then of course we have to convert that to a float and then change this to rotator dot interpolator. And then of course we're going to use the linear interpolator. Okay, so that's that. So let's run through this again. So basically the mover okay, is responsible for making the star fall. So this is responsible for making the star fall, and of course, supposed to fall in the Y, yeah, not X. So it's responsible for making the star fall. Okay, so it animates the translation Y property, similar to what we did with translation X in, where we did translation. Okay, but this one now causes the vertical instead of horizontal motion. Okay, so the code animates from a negative of the star height. Okay, negative of the star height to the container, the height plus star, the container height plus the star height container. So this actually just effectively places it just off the container at the top and moves it until it's just outside the container at the bottom. Okay, so the accelerator interpolator, okay, that's okay. We're just basically setting, it's just a setting on the star. It causes a gentle acceleration or movement. That's basically what that does. Okay. Now for the rotation on, okay, the star will just rotate the random amount between 0 to 1080 degrees. Okay, that's 3 times round. Okay, so for motion, we actually use the linear interpolator. Okay, reason is so that the rotation will proceed at a constant rate as the star actually what falls. Now, there are actually several interpolators actually. We have a path interpolator, but well, that's beyond the scope of what we're actually doing now. Okay, so the last thing, I think we should be rounding up very soon. So we're going to run the animations in parallel with the animator set. Okay, we now have to put these two animators together in a single animator set. We have to put it together. So how do we do that? Okay, now this is actually a very useful thing. Okay, for for slightly, we talk about the animator set, how useful it is for slightly more complex animation that involves multiple object animators. So the animator set is just a group of animations along with instructions on when to run these animations. So see it as a set of animations. Okay, animator set of what animators. So it can play animations in parallel or as we're actually going to do, or sequentially, like really you might want to do, in a when you have a list and you want to fade some items there. Okay, where you first fade out the first one and then animate the resulting gap to close. So so we're going to create an animator set. So I'm just going to say, so I'll say val. Okay. Animator set. Okay, of the animator set class. Okay, good. So, okay, so let's see. Another thing can be called animator, not animation. Okay. Well, we'll get there. Okay, so with our animator set, we can now call there's a play together, yeah. And they also want to play the mover and then want to play the rotator together. So another additional information is the duration. And then, of course, let's see. Let's get a random number. Okay. Let's do some mathematics here. And of course, I want to convert this to a long. Okay, so so what have we done? So once so we're basically just creating an animator set. Okay, and then we added the animators, okay, which is the mover and then the rotator, so that you get to play together. So now the default animation time of 300 milliseconds is basically quick. Okay, so we won't really enjoy, when the stars are falling. So we actually just set it a random number between 500 to 2000 milliseconds. Okay, so so basically, so we just did that so that the start falls are actually what they fall at different speeds. Okay, so once a new star has fallen off the bottom of the screen, of course, it should be removed from the container. That's actually the right thing to do. So so we'll just set a listener to wait for the end of the animation and then remove it, then start the animation. Okay. Now, remember, it should seem very obvious, okay, that when a new view is not needed anymore. Okay, when a view is not needed anymore, it should actually be what's obvious. So it should be removed. But complex animations can make you forget about those simple things. Like we could have just run this and then we'll say we are done. Okay, so that's where listeners come in. So I'm just going to say animator dot add listener. I'm just gonna call. So we have the animator. So animator listener adapter. Where are you? Okay. So we're just going to override the animation end. Okay, so we use the container to remove the view. And what view do we want to remove? The new star that just dropped. So once we're done, now I have to start this animator. Dot start. Okay, so let's see what we have here. Let's see what we have here. Let's see what we have here. Okay, so we'll click on shower. You can see that falls off the screen. So different sizes, different speeds. Yeah, so that's actually that. So I could click as fast as I can, and then I'll always get different values. Okay, so that's actually that. So this is we having a shower of stars, shower of stars multiple times. So the more you click, so when we click, we create a new star, a new animation for each time. So now we don't actually need to disable the button during this one. Okay, of course, because we want to actually create several simultaneous animations. So there's no problem with discontinuous motion here because each animation actually is independent of the others. Okay, so that's actually that. Okay, so yeah, so at this point, I'm going to take questions. Any question? So you can actually just read more about object animator sets, linear interpolator, and that they're good APIs to to understand when you want to write animations in your code. So yeah, I think this is that. So any question? Any question? Any question before we round up? Okay, so there are no questions. Okay, that's fine. So we're going to so I think in the next class, okay, in the next class we'll actually look at animations again, but this time with motion layouts. Yeah, I think that's what we're going to look at in our next class. Animation, but with motion layouts. Okay, so just get prepared for that, and of course, you can actually. I'm going to push this to GitHub so you can actually get that, and then play around with it. So I'm going to give you a task on this that's going to be for the weekend, and it's going to be a promotional task to stage 11. So let's get ready for that. Okay, so guys, thank you very much for attending the class. If you have any questions, of course, you can drop it on the channel and I'll be there to give you an answer. So thank you very much and have a wonderful night.
Thank you, sir.